Hey everyone, today I'm going to show you how to do multi-step going from grams to number of molecules, number of atoms, or you could flip this to go the other way as well. There's a couple conversion factors. I'll show you when you need them. Quick couple things. If you're using a calculator, you should be familiar with the E button. It may say E or maybe EE or maybe EXP. All right. Please use this button. All right. That takes the place of times 10. All right. So this means that. So if I'm trying to write 6.02 times 10 to the 23rd, all right. First of all, make sure it's in parentheses. And instead of writing times 10, right, you would write EE or EXP to 3, all right? Also, at the end of a problem, make sure that you are including your exponents because sometimes they're off to the side. All right, so let's go ahead and begin. You should already know how to do single-step problems, either going from grams to moles or moles to grams. You may already know how to do number of atoms to moles or moles to atoms. I usually teach that second, so you may not have heard about doing that. I'm going to show you how to do that here if you don't know how to go to number of molecules or atoms already. So let's go ahead and get started. So what's all this stuff about? Going from grams of something to maybe moles of something, or maybe you're asked, well, how many atoms or how many molecules are we talking about, right? We can actually theoretically figure out how many atoms or molecules should be in something if we're given grams. So let's take an example of that. Let's say how many atoms are in, and I should write this, so how many atoms are in I don't know, 247.00 grams. Let's stick with something we know. Let's just pick an element here, since that's nice and easy, of bromine, if we actually had that much bromine. All right. The first thing I like to do in a situation is just figure out what's going on in the problem. So I like to use directories. I look at this as a directory right here. This is my mighty directory of stuff. This will tell me how many steps I actually got to take on my railroad. All right. So over here, I am here. We are here. And our destination is all the way over here. All right. We actually don't want to know how many moles, but we literally want to know how many atoms, that is to say, how many individuals are inside those moles. So we're not interested in number of moles here. We're actually interested in the particles. How many bromine atoms? So I gotta set us up with some conversion factors here. The one that you've probably already heard of is this concept of molar mass. This is the one that we just pull off the periodic table, all right? I'm going to keep my conversion factors in boxes because when I put them over there on the railroad, they're actually going to appear very similar. So I've got to calculate molar mass. Fortunately, because it's an atom, I'm just going to go over here and I'm going to grab this wonderful periodic table and I'm going to go ahead. Bromine is right here. It's number 35, and I don't know if you can see that, but it says 79 70.90. That 70.90 is actually grams. 70.90 grams. And I'm actually going to be very specific because pretty soon we're going to start going between compounds and stuff. So we got to be specific with that molar mass. All right, grams of bromine. And it could be a compound. The question could be asking for molecules. It's still the same thing. If I had other elements here, I'd have to, of course, account for that and calculate the molar mass where you pull it off the periodic table. So this isn't just 70.9 grams. This is a very special amount. They just didn't pick a random weight here, okay? This actually works out for moles, right? So in 1 mole of bromine, okay? And it doesn't matter how I say this, really. I could also say there's 70.9 grams of bromine in 1 mole. Or I could write it this way. I could say that there is in 1 mole, there is 70.90 grams, let me just be specific, of bromine in specific, okay? 1 mole of bromine, it's the same thing, all right? The reason I'm pointing this out to you is you can go ahead and you can flip these to suit your needs. We're going to do that in just a second, just like we did before. All right, so just know that you can flip that and say it either way. The same goes for this other conversion factor, and I'm going to put it in a box too, just so that we're aware that we have these conversion factors. All right, in 1 mole of anything, in 1 mole of anything, there are 6.02 times 10 to the 23rd. And this, by the way, could be anything you want. It's literally, it's a number, right? So this could be atoms, it might be molecules, anything that can be itemized, you can have this number of. All right, well, maybe not realistically, all right? We would love to have this much money. We'd never run out of money if we had that much. Just remember, this is telling you it's a very large number. The exponent just tells you where the decimal is going, all right? So no big deal. And I'm just gonna call this amount in a mole. And indeed, we are going to be using it because moles, and we need to know how much is in that mole, all right? So I'm gonna go ahead and over here I'm gonna go ahead and work that problem. All right, so we're actually gonna turn that a little bit. All right, so here we go. Setting up the problem. All right, so now I'm gonna go ahead and I'm just gonna take what's been given to me. Right here, it says 247 grams of bromine. So I'm going to take that. You always start with what the problem is giving you. 247.00 grams of bromine. All right. So we're going to go ahead and I got to figure out. Now I know that this is going to be a 2-step equation. So I'm going to give myself, oops, we're really squeaky today. I'm going to give myself good space, right? It's a whole number, it's over 1. All right, so I've got 2 conversion factors over here. I have to use my brain and figure out what's going to be there. As always, you want to get rid of grams. To get rid of something, you want to divide. When you have these, this part right here means divide. So if I have this, this is over 1. It's divided by 1. It's a whole. So which one up here, which one of these 2 conversion factors has grams of bromine? Looking over there, that's this guy right here. I see grams, which is great. And I know in order to get over to molecules, I'm going to have moles. And it's also got moles in there. which is double great. So, all right, this is what I was talking about before. We can flip these to meet our needs. All right, we're gonna go ahead and I'm gonna actually flip it. I definitely want to flip it here. 0.90 grams bromine. All right. And of course, this is attached to it. So moles has to go on top. And this isn't just any old moles. This is moles bromine. All right. So you'll notice right here, we've used molar mass to go from grams to moles. We're now in moles. All right. We have gotten rid of grams. It's out of there. Cool. Now looking at the question, I didn't really want moles. I'm not doing this all for moles. All right, I'm doing this for atoms. So I need to know how many atoms are in a mole. Well, we know that. It's another conversion factor down here. All right. Interestingly enough, a lot of people tend to want to say they want to put 6.02 in this part. That's not quite right, because mole itself, if you just multiply this times 6.02, now you've got moles times 6.02. You want to get rid of mole because mole is a quantity and you want the individuals inside that quantity. You want this number, okay? So in order to get to the wonderful 6.02 times 10 to the 23rd, you've got to get rid of moles. So this is not going to wind up on the bottom. It's going to be your mole that winds up on the bottom. And that way, the mole part of it, the quantity part of it, just like a dozen, that quantity, you want that gone. You want how many is actually in that amount. All right? And if it was a dozen, we'd write 12 here, but the amount is actually 6.02 times 10 to the 23rd is 10 to the 23rd. All right? And that's it. That's your whole setup for this. Your setup is now done. All you're going to do is do your math step here, and I always just kind of leave myself some space. All right. And I apologize if this is really hard to see this. 2, 10. Okay. All right. So, and just a side note here, when I crunch this into the calculator, the way I'm actually going to put it in, so I'll put parentheses, 6.02 EE, or exponent 23. That's how I'm literally going to type that, okay? I'm not going to include the times 10. If you're finding out that you are an exponent higher than you should be, that's because you're putting that times 10 in there, all right? When you say EE, it's or the letter E, it's already, that times 10 is in there. So you're saying it twice. It's redundant to do it that way. All right, so I gotta grab myself a calculator. All right, from the stash, calculator stash. So here we go. In my math step, I'm gonna multiply across first. It just kind of, for me, it's easier to do it this way. 37, and then technically your times 1 times, and I'm gonna put parentheses around this, 6.02 EE 23. Okay, so make sure I've got this right. My top number is going to look like this, 0.4, limited to 2 spaces after, 4.9 times 10, and you have to remember on your calculator, it may not be uppercase, but for mine it is uppercase. I'm going to put that number, 10 to the 26. 26, and I'm going to do it one more time just to verify this, because I haven't actually worked this problem out. 247 times 6.02. Oops. I shouldn't have done that. I like to put everything in parentheses, so just to verify. 6.02. 23rd. Okay, good. We verified it, all right. And then 70 times 1 times 1.
All 10 players to the all 10 players, please report. Snap is waiting for you.
70, sorry, 0.90. Okay, once again, for this, when you type this number into your calculator, it gets parentheses, 49. I'm going to put that E, or exponent, 26. Okay, that's how I'm writing that in a calculator. Let's go ahead and do that. 1.49 EE 26. Right, close my parentheses. Can't afford to air condition everything. Divided by
all Frederick Douglass tennis players, please report to the Media Center. All Frederick Douglass tennis players, please report to the Media Center.
Okay, we're going to divide this by 70. Right, our final answer, we're finally there. All right, I'm gonna put it right here for us. All right, our final answer is 2.10 times 10, don't forget about your exponent, to the 24th power. Now, quick reminder, don't forget that you've got units, and this 6.02 is number of individuals, and that individuals is atoms. All right, so I really should have written atoms there, and specifically bromine atoms. All right, so atoms of bromine. Okay. This right here is my answer. Alright, I like to circle it. There's a lot of work, it's a lot of bookkeeping. But as always, if you are good with your bookkeeping, this is most of the work here. This is most of your credit for my class. And most, I think, chemistry teachers really want to see what your thought process is. So once again, as long as you take these, you're going to put them in here, all right? And they've got to cancel. Bottom line is you can flip them to do it however you want. If you're going from grams to molecules or molecules to grams, you're always going to wind up going to moles. It's always going to be a two-step. You can't just go molecules bypass to grams because your molar mass only talks to moles, right? The number of stuff only talks to moles. It's the number of stuff per mole. So you're always going to wind up doing that. But if this had been moles, I would have done the same. I would have done the reverse. I would have gone moles. Okay, I would have said,
Ms. Bones, Ms. Bell, please report to the conference, to the counseling center. Thank you.
Sorry, if this had been moles, it would have been a one-step. I would have gone straight to grams that way. But if this was number of atoms, then I would have had to go number of atoms, 6.02, and then moles would have been up here. I would have wound up doing grams.